which is altogether a new topic for you. So electric flux, let's begin with electric flux. By the term electric flux, it is very much somewhat different with electric field. Electric field haibaga electric flux haibaga khenagani kamai khenagani haibaganda ekoina surface ama leire. You will have a particular surface like this, and on this surface if you have electric field lines passing through the surface like this, electric field lines are passing through. Electric field lines in want to pass through uniform way non-uniform way, and these electric field lines, let us say, corresponds to E vector. This E vector is the electric field intensity corresponding to the electric field. Then this electric flux will be defined as the number of electric field lines. Here you have 4 field lines passing through the surface. However, depending on the shape and size of the surface, this number of electric field lines may vary. This number of field lines passing through the surface, normally this number of field lines is known as electric flux linked with this surface. Maitairon hai taragadi ekoina surface amada phawriba electric field lines ingi masing do madu ekoina electric flux haraga khangani. So you will define electric flux as the total number of electric field lines passing through a surface, normally. Why normally? Because we are going to take the vertical perpendicular component. That's why we are saying it as normally. Aduna, this is the very definition of electric flux. And amuka hana haige karigumba surface amasi electric field da thamba taragadi surface to the power river electric field line gi masing do madu ekoina electric flux haiga khangani have yareko. Aduna haiba definition sidagi ekoina magi formula laigani how to find electric flux haibagi. For every type of surface, when you have a surface of any shape, it may be square, rectangle, or any geometrical shape, on that surface you can draw a perpendicular like this, right perpendicular, perpendicular. Then if the area of this vector, area of this region, surface to the E wherever, then there is a vector which is perpendicular to the surface, which is denoted by A vector, and it is called area vector. And the area vector C perpendicular to the surface of the dome. This is known as area vector. Similarly, here in our definition of electric flux, at this point you can draw an area vector like this. This is called area vector, A vector, This is nothing but area vector, and what is this? Electric field intensity. Then there should be, as you see from figure, masida angle amalagini. This particular angle, let us name it as theta. Theta is an angle between E vector and A vector. This term electric flux is mathematically written as pi equal to E vector dot A vector. It's my defined term. So the mathematical definition of electric flux linked with the surface is the dot product of electric field intensity E vector and area vector hydro. And likewise that. Aduna, let me just define it again. Amuka hana highway electric flux hybase surface amada link to electric flux hybase electric field intensity E vector ga area vector A vector ga ani sigi dot product to ni haven. Dot product haven cross product haven na ko. Aduna, by definition of dot product ke definition ni matungina koi sida define torsi doita agadi phi se kramai irasu yare E A cos theta ine irasu yare E A cos theta yare ko aduna this is the mathematical formulation of electric flux. Then if you have a small area, small shaded area, let us say see a people region say see region see area say ds ne la say small area very infinitesimally small area ne la lower. Then when you have an area, there should be a vector which is perpendicular to the area. I know mamang the high you know. ds high area sigi sumagi area vector high one like let that ds vector be here. Go. When the area is very large, area do yam chaw bukanda more number of electric field lines will pass through. Area yam chaw di field line machine yam pass tawni. However, when the area is very small, the number of field lines passing through will be very small. Say, areas are the field line mayam pass on area the field line khajikang pass on having. It is very simple reason. Other with the small flux small flux kadai the power see area ds the power small flux d phi se masi se kariga mane have kanda E vector dot ds vector gamana niya. So what is d phi? D phi corresponds to the small electric flux linked with the small area ds. Yari ko. Adu iba taragadi. If you want to find a total flux linked with the whole surface is the power of the electric flux though. Madu puthoke have targadi, you will take the help of integration. Last time I told you integration dx is equal to x. That's why I wrote integration dw is equal to w. Is that okay? Then likewise, if you want to find the total flux linked with the whole surface, then this phi can be written as closed surface integration of the phi and the low name. So this integration is a surface integral. That means integration is done on 2 dimensions. Integration is along a line that's a 1-dimensional body the integrate that is called line integral. But when integration is done over a surface 2-dimensionally, the type of integration is known as surface integral. Alright. So you will write read it as phi is equal to closed surface integral of d phi. But d phi is already equal to E vector dot ds vector. So let us substitute the value of d phi from here. Let us substitute or say, then how will you write? Phi equal to closed surface integral E vector dot ds vector. So this is the integral representation of electric flux. Electric flux and putok hai targeti E vector dot ds vector to dot product logo lo integration surface integral you will find the total electric flux. And depending on the situation, whether the given charge is a continuous distribution or non-continuous, discontinuous, we are going to use either the first one or the second one. Aduna sige definition ani mak se khanggadawni. Amukan haige this electric flux can also be expressed in terms of integration as the closed surface integral of E vector dot ds vector. What is E vector? Electric field intensity. What is ds vector? Area vector. Alright. Then ani sige definition si khangba loirba matungda nangna kari amuk uthokpa yagani haiba kanda phi haibasi magi SI unit na karino aduga masi scalar oigadra vector oigadra haiba yengs. Phi, as you know from the first definition, this phi, this is equal to A cos theta. So this is the first definition. Let us think over here whether it should be vector or scalar. E is a vector symbol. This is a scalar quantity which has only magnitude but no direction. Area have see how much meter square, how much centimeter square like have see. This is always a scalar quantity. Cos theta value is always a scalar, right? Scalar quantity because as you know, let us take an example. Cos 30 degree high say root 3 by 2 root 3 by 2 is always a scalar quantity. It doesn't have direction. It just have has only magnitude, my direction. So the whole quantity on the right hand side of equation number 1 is a scalar quantity. That's why this electric flux is always a scalar quantity. Now let us think about the SI unit. SI unit puthokse. SI unit puthokpa taragadi kari lani haiba kanda. In the SI unit, let us think SI unit of phi. Now electric field unit, you try to recall electric field have see force by test charge and how was the unit? Newton. Force ki Newton coulomb se makha le charge makha le Newton per coulomb area ki unit kari area have see meter square cos theta value see equina unit it is unitless. So your unit for the SI unit of this phi will be Newton meter square per coulomb. So this will be the SI unit of electric flux. Then asi khangi higher kanda electric flux se karam kind maximum or any kind minimum or any have say for a given surface amagi magi area se fix or any E fix or any electric field strength E fix or any, then on which factor does it depend? Phi values it depends on then it depends on the value of theta. The way how you keep the charge surface in the electric field, the orientation, depending on that orientation, this phi value will differ. Theta is 0 cos 0 1 and under that condition phi will be maximum. karigumba theta aduna mo karigumba 90 oiba tarigi cos 90 is 0 ne adugumba kanda mo phi je mo kari hoy ni amu minimum hoy ni. Let us see the situation. Aduna let us think of the first condition. When you have the electric field lines like this, electric field lines this mine lere aduga nangna surface to directly perpendicular way na thame high surface e, then E vector som kanda lere, area vector A vector same direction da lere. Then in this case theta will be how much? Theta is kya hoy ni same direction lemina 0 degree hoy. That's why your phi will be EA cos 0 degree. Cos 0 di kya no 1 ni aduna masi EA khakta taran. And this value of EA will be maximum. Okay, the way maximum or to na second case lagu kan khangani. Alna cos 0 se sida more number of field lines, maximum number of field lines will pass through the surface when the surface is placed perpendicular to the direction of electric field highway. Then in the second case phi se muku those karamba kanda surface se sumaina thambagi mahutta, instead of keeping the surface like this, let us keep the surface like this. So along the surface se sumaina thamben khalo. Then E vector somno kanda lere, area vector somno kanda lere, then obviously this angle will be how much? Kaya hoy ni 90 degree hoy ni natra adu ita agadi EA cos 90 lani cos 90 di kya no 0 ni matam maramaduna masi 0 tarni. That's why phi will be minimum here. So you have two conditions now karino madudi phi will be maximum when the surface is placed perpendicularly to the direction of electric field, and phi will be minimum when the surface is placed along the direction of the electric field. Yareko phi maximum and minimum will be every condition singse sini aduga when it is placed just in oblique, depending on the angle the value of phi will be different. Yareko aduna phi value different oigadori se karam kan oirakani have kanda my angle theta do right o kudimaki phi value do dum change tawkani sin. So this is all about electric flux. Electric flux ki matang ne ino to hai se. Now from this electric flux there will be very important theorem that comes after a few classes, and amadu lakringai matamda types of charge distribution haiba makhangna wanasi types of charge distribution. Let us see the first type. Number 1, linear charge distribution. Linear charge distribution. Here, linear harmony, as the name suggests, it will be one-dimensional or body oidurini. So when you have a line or one-dimensional body, it will have a length L high, and let us say some charges are distributed uniformly on the surface or on the line. Let us say positive charges are distributed on it like this, right? And how much charge is there? Q, right? And such a uniform distribution of charge over a line, this is known as linear charge distribution. Company. For this particular type of charge distribution, there will be linear charge density, lambda. It will be denoted by lambda. Lambda is sometimes wavelength denote, but here in this case you will signify this lambda as the linear charge density. So this linear charge density will be defined as the total charge divided by total length of the line. Total charge divided by total length. This is known as linear charge density. then I high charge distribution in case if you take a small length of the line, a big length of the line is low target. Let us say instead of L, instead of taking the whole length and taking the whole charge, if the length of the line is only DL is kata sangaba, and obviously charge enclosed by this DL will be very small, DQ. Alright, then this charge density lambda can be written as dq by dl. dq by dl. So this is the mathematical definition of the charge density, linear charge density actually, and dq by dl or q by l. What is the difference? Q by l is total charge by total length, and dq by dl is the small charge divided by small length. Okay, so how about the unit then? Unit kari hoini, SI unit kari hoini today. Charge unit kari no coulomb ni, charge unit is coulomb, distance unit is meter, then this will be coulomb per meter. So this is the SI unit of linear charge density. Alright, so this is the first type of charge distribution. Charge makal distribution ki ahan type. Then let us go to the second type then. Instead of writing linear highway surface charge distribution highly. So instead of taking a one-dimensional body, we will take two-dimensional body. That means a plane the thambaya body shape lower. Let us say this shape. Okay. Then obviously this particular surface will have an area. Area to A and charges are distributed. Charge ki angat property amana karino when you induce any amount of charge on a particular body, it will just distribute equally on the surface. And smile like that. So the total charge enclosed within or distributed on this surface is Q. Then such a charge distribution is known as surface charge distribution, and for this also you will have charge density. Charge density will be denoted by this symbol sigma. This S-like symbol is known as sigma. S man symbol say must is a sigma sigma denoted by sigma, and it will be equal to total charge by area. Masai surface charge distribution da charge density doi koina charge by length haina leidana adu gi mota koi hojina charge by area haina lakne adu degidi masigi kaino si charge sigma qc sigma si koina masai gi thmaina small area big area ama nang si da low ta gadi the small area dA loraba charge to man mai manung da leba charge so dum obviously p ani charge dq over ta gadi sige sigma se dq by dl hai mo the dq by dA oirani. So this is the second definition, second type of charge density. Then kari hare charge divided by area. Previous one na charge divided by length. Then SI unity kari oirani coulomb per meter or coulomb per meter square oirani. So you have the two types of charge distributions now. First one linear charge distribution. Second one surface charge distribution. Now let us go to the third type of charge distribution. Ahum suba type of charge distribution ama lower se madudi number 3 da this is known as volume charge distribution. Volume charge distribution is obviously we will be dealing with volume of a three-dimensional object. Say three-dimensional object amma hector lower see on the surface of the object you will have the charges distributed equally. like this, any three-dimensional object. Then the volume of the object will be V, and this is the total volume, and the total charge is Q. Then charge density will be denoted by, instead of sigma, you will write rho. Rho có equal to symbol sa. Si man với symbol sina rho có RH rho. You might have come across in class 10. Then charge density से combine define only have kanda charge density से charge divided by volume hai la ne. But similarly here in this case also, the sigma will be dq divided by dv and la. When you take a small volume here, a big volume amanang sida then volume will be dv, small charge enclosed will be dq. Then obviously this rho will be equal to dq by dv. Then how much will be the SI unit? Very easy now. It will be coulomb per meter cube. So this is these three types of charge distribution will be very much useful when you come to Gauss law and its applications. Okay, so you have to definitely know the three types of charge distribution and their corresponding charge densities. This is very important.